Hey everyone, it's Ken. In this video, I'm going to show you an example of computing a definite integral straight from the definition and also using our understanding of geometry. And so the integral that I want to look at is one of the simplest ones. I just want to look at the straight line, y equals x. And here's a graph. Let's integrate it from 0, a equals 0, to b equals whatever it is. And this is going to be our goal for this video. Integrate x from a to b, but actually a is going to be equal to 0. And so knowing that the integral is the signed area under the curve, in this case, since the curve is straight line and it's always positive, or non-negative at least, the signed area is just going to be the area of this triangle. Area of a triangle, of course, is half of base times height. The base is equal to b, so 1/2 base times height. What's the height? Well, it's going to be this length here, but since it's y equals x and x is equal to b, the height is also b. So the answer needs to be b squared over 2. That's what our geometry tells us. And what I want to do now is to see if we can recover this same answer using the definition. And let's use right-hand endpoints. So the integral from a to b of x dx, by definition, that's equal to limit as n goes to infinity of the Riemann sum. I goes from 1 to n, of f of xi. F of xi is just xi times delta x. So this is the formula for right-hand approximation of the area, and then taking a limit as n goes to infinity. So that's got to be the answer. That's got to be b squared over 2. So how can we get that? Well, I have to remember what these things mean. And so delta x, that's b minus a over n. So that's b minus 0 over n. And what about xi? Well, xi, the formula is a plus I times delta x. A is equal to 0. I times delta x is going to be I times b over n. So let's plug that in. Taking the limit of I times b over n times b over n. And summing up from I goes from 1 to n. So how can I fix this? Or how can I progress forward? Well, this is just a sum with n terms in it. And the variable here is I. I start out with plugging in I equals 1. I get b squared over n squared plus 2 times b squared over n squared plus 3 times b squared over n squared, all the way up to n times b squared over n squared. So you'll notice the constant there is b squared over n squared, which I may as well just factor out. So let me go ahead and do that. Let's limit as n goes to infinity. B squared over n squared. We're getting a little bit closer to our answer. And now the sum, I goes from 1 to n, of the first n numbers. And so here's where some of our previous work really comes in handy, because we've already figured out a formula for the sum of the first n numbers. Remember, this formula was equal to, wasn't it equal to n times n plus 1 over 2? Right? And now what we can do is a little bit of algebra. I've got n squared downstairs and n upstairs, so I can cancel one of those out. Just limit n goes to infinity. So canceling that out, I'm going to get b squared over 2. And then what's left over? I have n plus 1 divided by n. And you see what I did? So one factor of n went away, and I'm left with n plus 1 over n. And then I just moved the 2 over. So I get b squared over 2 times n plus 1 over n. And we're almost finished. This is a constant, b squared over 2. I can pull it outside of the limit. That's the limit law. Let me continue writing up here. Get a little bit more space. So b squared over 2 times limit n goes to infinity of n plus 1 over n. And I'm going to rewrite that. This is n over n, which is 1, plus 1 over n. N plus 1 over n is the same thing as 1 plus 1 over n. And so what's this limit? Well, the limit law says this is the limit of 1, which is just equal to 1, plus the limit of 1 over n. Limit of 1 over n as n goes to infinity. N's getting huge, 1 over n is getting infinitely small. That limit is 0. So I end up with nothing but b squared over 2 times the number 1. And that's great, because that's exactly what I knew it had to be from my geometry insight. But I was also able to give a formal proof of that, the integral from a to b, where a is equal to 0 of x. I'm calculating it from the definition with right-hand endpoints. Just using the fact that I know the sum of the first n numbers, plugging in that formula, taking the limit, got me right to the answer.